Aryaman, one thing that you need to remember whenever you are calculating the LCM is that just remember, just focus on this word, common multiples. So basically what we have to do is we have to extract the common multiples. Now, the easiest way of calculating the LCM is that you make a grid like this. So, for example, if I'm doing this question 468, so I make a grid like this. So from 468, which is the common multiple? So the common factor is 2. Any doubt about this?
No, no doubt.
So first, I've taken the first factor out. So 2 is the common factor out. So 2, 3, 4 remains. Any confusion in this step?
No.
Again, what I see is I can, take out the common factor 2 from 2 and 4. So I ignore 3. That is not an issue, but I take a common factor from 2 and 4. So when I take a common factor from 2 and 4, so 2 ones are 2, 2 twos are 4. Again, 3 is as it is. I am not bothered about 3. Now, 1, 3, 2, the only common factor that I have is 1. Only when the common factor is 1 does the process stop. Any doubt about this?
No.
Okay. And now the LCM, it has to be written as multiplication of 2, 2. These are the common factors. I can ignore 1 and 3 here and 2 here. So what I have written is 2 into 2 into 3 into 2. Any doubt, Arem?
No, no doubt.
And the answer is 24. So the LCM of 468 would be 24. Any doubt?
No.
Just remember this step, that this grid will stop only when the common factor of the numbers is 1. Once the common factor is 1, that the process stops. Any doubt?
No.
Now, I'll go into a little bit of depth to make you understand what does the LCM signify. So for example, 4 multiplied by 6 is 24. Any doubt?
No.
6 multiplied by 4 is 24. Any doubt?
No.
And 8 multiplied by 3 is 24. Any doubt?
Also, it's the lowest
Yes.
common
Yes.
number that they both.
Yes. So if I write that is why I told you in the beginning that you have to find the common multiple. So for example, if I write the common multiples of 4, so 4 ones are 4 2 the, 4 3 the, 4 4 the, 4 5 the. So it will be 4, 8, 12, 16, 20 and so on. Similarly, I can write the common multiples of 6. So 6 1 the, 6 2 the, 6 3 the, 6 4 the, 6 5 the, 6 6 the. I can write a series of, infinite number of multiples of 6. Similarly, I can have series of infinite numbers of multiples of 8. 8 ones are 8, 2s are 8, 3s are 8, 4s are. Have you any doubt till here?
No.
Now, in all these infinite series of 4, 6, 8, the multiples of 4, 6, 8, what I want is the least common multiple. Have you understood?
Yeah, the lowest.
Yes, the lowest. I want the lowest common multiple. So if basically in very simple terms, what it means is that if I write the tables of 4, if I write the tables of 6, I write the tables of 8, which is the first number, which will be the least number that would be common in all the 3 tables. Have you understood?
Yeah.
So if we take any example, so let me take this example. So 10, 15, 20. I write the tables of 10, I write the tables of 15, I write the table of 20. Now there would be the least common multiple of 10, 15, 20 would be the LCM of 10, 15, 20. Any doubt?
No.
And the way to find the LCM is this is the grid that is always made. This is the easiest way in doing this question. Any doubt?
No.
So now try to do what I'll suggest is try to do till 5. Try to do. Yeah.
One is so do.
Actually you can start from second, third, fourth, fifth. Great. So if you look at the second question, 9, 12, 15, is this how you have done it? 9, 12, 15. First, the common
Yeah.
factor is 3. Your answer should be
Then
180.
it's, yeah, I did that.
You have followed the same process?
Yeah.
Great. Second, 5, 10, 15. Have you followed this process?
Yeah.
Is your LCM 30?
Yeah.
Great. Next question, 7, 14, 21. Is your answer
Or
42?
yes. The next one is 2, 4.
No. Is your answer 42? Is it 42?
Yeah.
Okay, great. 8, 12, 18. Is the answer 72? Have you followed the same process?
No, I got 2, 4, 4.
2, 4, 4. Okay, let us see. Let us
I
see.
started instead of 2.
Okay, so it is always suggested. See, this is called LCM by prime factorization. Have you understood?
Oh,
By
we
prime
have to do
factorization.
it.
Yeah. So it is always suggested that you use prime numbers. So once you have the experience, of course, you can go directly to 4 also. That is not much of an issue. So I have written here prime factorization. That is why I have taken the prime numbers also. So, but whatever process you follow, the answer should be the same. So I took 2, then again I took 2, then 3 was a common factor. Yeah, 3 was a common factor, and my LCM was 12 to the 24, 3 to the 72. So is your LCM 72?
No, I got, so basically my numbers were 6, 2, 4, 1, 3. And then I have no idea what I did.
No, then what was your answer? What was your LCM?
2,
I'm sorry?
2, 4, 4. 2,
2,
4,
4,
4.
2, 4, 4. Okay. So see, if you follow this process, your 72 is the first common multiple. Again, see, 244 of course will come. 244 will come later. Have you understood the logic?
Yeah.
So 244 will come later. 1 second, I'll tell you. 244 is 72. 73. I think 244 might be incorrect. I'm not sure whether this is the correct answer. Yeah. 72. See, 216. 216 is the correct answer. After 216, the next number would be 288. So either it should be 216 or 288. I think there is some problem with 244. But have you understood the logic?
Yeah.
So this is the best method that you take the prime numbers, and this will taking the LCM helps us a lot in addition and subtraction of fractions. So in the next lecture, we'll be doing the addition and subtraction of fractions. Have you understood?
Yeah.
I'll send you a few questions to practice. You can do all these basic questions. You can practice. And if you have any doubt, we'll discuss LCM or we'll do addition and subtraction of fractions. Any doubt, Mr. Arvind?
No, no, no.
Great.